Okay, so as in the last video, we discussed some general terms. For example, pure vapor pressure of A, which was denoted by P naught of A, and then pure vapor pressure of B was denoted by P naught of B, which means only their vapor pressure is present. They have not been mixed yet. However, they are present separately. After mixing, we got their partial pressure, right? And partial vapor pressure of A is denoted by PA and partial vapor pressure of B is denoted by PB, right? So then we started discussing about Raoult's law, which is very important. Let me write here the head. Raoult's law. What does he say? He says in a solution, the vapor pressure of each component is directly proportional to the mole fraction, and we have already discussed about mole fraction in very detail, right? But I'll give you here an example of it, so it must be more clear, right? Fraction of that component now. See, let's read it again and let's form the equation then, right? In a solution, which means now we have a solution. For example, we are taking this example, right? In a solution, the vapor pressure of each component means the vapor pressure of A, the vapor pressure of B, each component is directly proportional to the mole fraction of that component. If we have a vapor pressure of A, so vapor pressure of A would be directly proportional to the mole fraction of A, right? That component. Mole fraction, the vapor pressure of B would be directly proportional to the mole fraction of B, right? You can either use zeta sign or y1 sign, right? So in a solution, the vapor pressure of each component is directly proportional to the mole fraction of that component. Now see, if I need to have a vapor pressure of PA, right, means partial vapor pressure of A is directly proportional to the mole fraction of A, right? And if I want the partial vapor pressure of B, so partial vapor pressure of B is directly proportional to the mole fraction of B, right? Now we must know what is mole fraction. I have already told you about mole fraction, what it is. For example, if you have a solution, right? So now you have two substances in it, right? Solute plus solvent, or you have two solute in it, right? One solute has 3 moles and other solute has 2 moles. This is A, this is B. So A has 3 moles, B has 2 moles. If they ask you to find the mole fraction of A, right? So then you need to use this 3 in the numerator and 3 plus 2 in the denominator. So 3 plus 2 is 5, right? And then if you want to find the mole fraction of B, then put the B moles in the denominator, which means 2, and 3 plus 2 is 5. And if you will gonna add these both together, they will always be equal to 1. For example, 3 plus 2 is 5, since 5 is same in the denominator, right? So 5 by 5 is 1. So denominator would always be equal to 1 either you have two components or you have three components, the mole fraction, the sum of mole fraction of each component in the solution would be equal to 1 only, right? Now if I remove this proportionality sign, what will I get here would be PA is equal to P naught of A N A, which is mole fraction of A, right? So here we'll gonna get a constant which is known as pure vapor pressure of A. Pure vapor pressure of A. Now here you can actually find partial vapor pressure by multiplying the pure vapor pressure of A by the mole fraction of A. But if you want to find the pure vapor pressure of A, then you need to divide partial vapor pressure of A by mole fraction of A. Alright, here too, when we are gonna remove this proportionality sign, just wait for a while. Yeah, so when we gonna remove this proportionality sign, we're gonna get here is equal to n constant, which is P naught of B, and NB, which is mole fraction of B. Now what this represents pure vapor pressure of B, pure vapor pressure of B, right? So in a solution, the partial vapor pressure of each component is directly proportional to the mole fraction of that component. PA is directly proportional to the mole fraction of A. PB is directly proportional to the mole fraction of B. When we remove these both proportionality sign, we get is equal to n constant, the pure vapor pressure of A in the case of A, and the pure vapor pressure of B in the case of B. Alright, in the next video we're gonna apply the Dalton's law, and we're gonna have the total pressure, right? So this was all for today.